All right, in this video, we are going to practice converting between Fahrenheit, Celsius, and Kelvin. So we have our equations right here. A lot of times you'll see this 1.8 as 9/5, but I think it's easier just to say 1.8. And then we're also just using 273 in our Kelvin conversion instead of 273.15. So if you wanted to be more specific, you would add the 0.15 here, but we're just going to use 273. So here's our first question. A sample of air is at 425 Kelvin. What is the temperature in degrees Celsius? Okay, so we're given 425 Kelvin, so I'm going to underline it. And we're looking for degrees Celsius, so I'm going to circle it. So if I look at my equations for which one has Kelvin and degrees Celsius, it's the second one here. So K equals degree C plus 273. Okay, now I'm going to take my Kelvin and plug it in for K. So 425 Kelvin equals degree C plus 273. And then to solve for degree Celsius, I'm going to do the opposite function. So if I'm adding 273, I'm going to subtract 273 from both sides. This would be 0, and then 425 minus 273 is a 152. Okay, now this is typically kind of what you would see in math where you're equaling your variable, but since this is a measurement, we want to write whatever number we have, so 152. And then our measurement or our unit, so degrees Celsius. So that's our answer for number 1. Okay, if we take a look at number 2, a reaction is performed at 150 degrees Fahrenheit. What is the temperature in degrees Celsius? So I'm given 150, so I'm underlining it. And I'm looking for degrees Celsius, so I'm going to circle it. So which equation has both? That's going to be this first one. So I'm going to rewrite it. Degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. So I'm going to plug the 150 Fahrenheit in for the Fahrenheit, okay? So 150 degrees Fahrenheit equals 1.8 degrees Celsius plus 32. So if I'm trying to get degrees Celsius by itself, I'm going to first get rid of this 32. I need to subtract it from both sides so I can get degrees Celsius by itself. So this is 0, and then 150 minus 32 is 118. So 118 equals 1.8 times degrees Celsius. So to get degrees Celsius by itself, I need to move this 1.8. And since I'm multiplying here, the opposite function is dividing. So I'm going to divide both sides by 1.8. So the 1.8 and the 1.8 cancel. And then I'm going to take my 118 divided by 1.8. And this is 65.5555555. We're just going to use 2 decimal places. So the 5 would round this 5 into a 6. So our answer would be 65.56 degrees Celsius because I solved for degrees Celsius. Okay. All right, let's take a look at the next one. A liquid cools to negative 12 degrees Celsius. What is its temperature in Fahrenheit? So I'm given the negative 12, so I'm going to underline it, and I'm looking for degrees Fahrenheit. So I'm going to end up using the same equation I used in this last one because it has Fahrenheit and Celsius in it. So I'm going to rewrite it. Degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. And since I have degrees Celsius, I'm going to plug that in for my degrees Celsius variable in the equation. So my degrees Fahrenheit equals 1.8 times negative 12 degrees Celsius plus 32. So the first step is to multiply these two together. So 1.8 times negative 12 is negative 21.6. So this part is negative 21.6. Then I'm going to add 32. So negative 21.6 plus 32 is 10.4. So my answer is 10.4 degrees Fahrenheit because that is what I set it up to solve for, and that is what the question asked me to find. Okay, now let's take a look at the next one. A sample of gas is measured at 77.0 degrees Fahrenheit. Convert this temperature to Kelvin. Okay, so I'm given degrees Fahrenheit and I'm looking for Kelvin. Well, if I think about my two equations, right? Degrees Fahrenheit is 1.8 times degrees Celsius plus 32, and Kelvin equals degrees Celsius plus 273. I don't have an equation that has Fahrenheit and Kelvin in the same one. So I'm going to have to make a stop at Celsius. So my plan is to go from degrees Fahrenheit, and I'm going to convert that to degrees Celsius, and then I'm going to convert that into Kelvin, okay? So let's start finding degrees Celsius. So I'm going to take my 77 and plug it in for the degrees Fahrenheit in this first equation. So 77 degrees Fahrenheit equals 1.8 times degrees Celsius plus 32. So I'm going to subtract 32 from both sides so I can get degrees Celsius on its own. So 77 minus 32 is 45. So 45 equals 1.8 times degrees Celsius. So to get degrees Celsius by itself, I'm going to divide both sides by 1.8. Those cancel, so I'm going to take 45, which I have as my answer, divided by 1.8, and it gives me 25. So our degrees Celsius is 25, okay? But we're not done. So looking at our plan, we did this first step, so I'm going to cross it out. So we went from Fahrenheit to Celsius. Now I'm going to take my Celsius and plug it in to my second equation to solve for K. So Kelvin equals degrees Celsius, which I just found to be 25, plus 273. So I'm taking my 25 plus 273, and that's 298. So my answer is 298 Kelvin, okay? And just to be sure, I went from Celsius to Kelvin, so I'm going to cross that out. So there's our answer, 298 Kelvin. Okay, let's take a look at the next one. A chemical reaction is carried out at 315 Kelvin. What is this temperature in degrees Fahrenheit? So I'm starting with 315 Kelvin, so I'm underlining it, and I'm looking for degrees Fahrenheit. So this is starting at Kelvin, and I'm going to Fahrenheit. But the problem is that I don't have an equation like these two, like the previous question, that goes directly from Kelvin to Fahrenheit. So I'm going to have to stop at degrees Celsius along the way. Okay, so that's the first thing we're going to do is go from Kelvin to Celsius, so then I can take my Celsius to find Fahrenheit. So 315 Kelvin equals degrees Celsius plus 273. So I'm just using that same equation that we've used before. Minus 273 from both sides. So 315 minus 273 is 42. So this is 0. So now we have 42 is our degrees Celsius. And remember, when we rewrite this, we put our unit at the end, okay? So 42 degrees Celsius gets us the first step. So we are here, but that's not our final answer. So we're going to take our degrees Celsius and plug it into the next equation for degrees C. So using the Fahrenheit and Celsius equation, Fahrenheit equals 1.8 times degrees Celsius. So I'm going to plug this in here, 42. Okay, sorry, I had to get the white out. Okay, 42 degrees Celsius plus 32. So I'm going to solve this part first. So 42 times 1.8 is 75.6 plus 32 is going to give us degree Fahrenheit. So 107.6 degrees Fahrenheit is the final answer. So we completed the second step to get to the final one. So that's how we convert between Celsius, Kelvin, and Fahrenheit.